Section 2.1 is called Solving Equations with the Addition Properly. In this section, we're going to work on solving algebraic equations. We'll start with one-step problems and move to doing multi-step problems in the same problem. But before solving algebraic equations, let's work on verifying whether or not a given solution works in an equation. For instance, let's say that you have the equation 2x plus 4 is equal to 10. And you're asked if 3 is a solution. In order to find out whether or not 3 is a solution, all you have to do is put 3 in for the x in this particular equation and solve it and see if it's true. So if I do that and put a 3 where the x is, I can then go through and solve this and see if I get an answer of 10. Well, 2 times 3 does equal 6, and then 6 plus 4 does give me 10, so 3 is a solution for that particular equation. Sometimes you might have x on both sides of the equation. Is 5 a solution for this particular equation? Well, the way to find out is to put the 5 in where the x is on both sides and solve. So if I put the 5 in on both sides, on the left side I have 2 times 5 minus 1, and on the right side I have 5 plus 5. If I solve both sides, 2 times 5 is equal to 10, 10 minus 1 is equal to 9, so on the left hand side I have 9, on the right hand side I have 10. So in this case 5 is not a solution for that particular equation. You may be wondering if equations can have more than one solution. They certainly can. For instance, if you have the equation x squared is equal to 9, you're asking yourself, what could x be squared to equal 9? Certainly one possible answer for that would be 3, because 3 squared is equal to 9. But another answer for that could be negative 3, because negative 3 squared, negative 3 times negative 3, is also equal to 9. So in this particular case, I have two different solutions for this. X is equal to 3 and x is equal to negative 3. But one thing to notice with this, notice that in this particular problem, I have x squared. Because I have an exponent of 2 associated with the variable, that means that I can have up to 2 different answers. Most of the time in this section, we will just be dealing with equations that are just with an exponent of 1 rather than a different exponent. There is a name given to this type of an equation. This type of an equation is called a nonlinear equation. And the reason it is a nonlinear equation is because I have the variable raised to a different power other than 1. In this case, as I say, it's raised to the second power. Earlier, we were working with some other equations. For instance, x plus 3 is equal to 4. This is known as a linear equation. And it is a linear equation because the x term that I have is just raised to the first power. If I wanted to, I could put a little 1 there with the x to the first power. Normally you don't do that, you just leave it with the x, but that means it is a linear equation. Speaking of equations, remember that in order to be an equation, you need values on each side of the equal sign. So when you have x plus 3 is equal to 4, that is an equation, and as I said, that is a linear equation. If you just have something like x plus 3, but there is no equal sign there, that's not an equation, that is just called an expression. And some of the exercises in your book ask you to delineate between telling whether or not something is a nonlinear equation, which means that the variable is raised to a different power other than 1. A linear equation is just raised to the first power, or if something is just an expression, there is no equal sign there, it's just an expression that you are giving. So now, let's talk about solving algebraic equations. In order to solve an algebraic equation, there is one goal in mind. Get the variable on one side of the equation by itself. One rule to remember: whatever you do to one side of the equation, you must do to the other side, so the equation stays balanced. So, let's say that you have an equation x plus 9 is equal to 11. We all know that the answer to that is 2, because 2 plus 9 is equal to 11. But it is important, even in these early steps, that you show your work on how to get the answer of 2, so that later on, when the problems are more complicated, you have a method for doing them. Right now, I don't have the x, the variable, all by itself. I have plus 9. So what I'm going to do is I'm going to subtract 9 from that left-hand side. If I subtract 9 from the left-hand side, I also have to subtract 9 from the right-hand side. And it's very important that you show this. Now I'm going to go through and I'm going to simplify both sides. So if I have x plus 9 and then minus 9, I'm just left with x on the left-hand side. And on the right-hand side, 11 minus 9 is equal to 2. One of the nice things about doing equations is that you will always know if you are right or not. Now, obviously, this is a very simplified equation. But if I'm saying x is equal to 2, I can put it back into the original equation and check to make sure that it is true. And certainly, 2 plus 9 does give me 11 for an answer. Here's another example. Once again, simple, I know, but I want to make some points here. X minus 4 is equal to 6. In order to solve that, I have to get the x all by itself. Right now it's x minus 4. So I'm going to do the opposite of subtracting 4. I'm going to add 4. I'm going to add 4 to both sides. Then I'm going to go through and I'm going to simplify both sides. So I get a final answer of x is equal to 10. Because the minus 4 and the plus 4 really cancel each other out, leaving me just with that x. Once again then, if I put 10 back into the original equation, 10 minus 4 does equal 6, so I do have the right answer. In the first two problems I gave you, the x was always on the left-hand side of the equal sign. But certainly it does not need to be that way all the time. Here I have 17 is equal to x plus 11. I want to get the x all by itself. This time the x is on the right-hand side. So I'm going to go through and I'm going to subtract 11 from the right-hand side, which means I need to subtract 11 on the left-hand side. When I subtract 17 minus 11, I get 6. On the right-hand side, I am just left with my x. So now, 6 is equal to x, or I could be saying x is equal to 6. Once again, I can put that back into the original equation and make sure that it does work. Sometimes when solving equations, you might have x's on both sides of the equal sign. Remember, the idea is to get an x all by itself on one side of the equal sign. In order to solve this, one way to go through and do it is to subtract 4x from both sides. If I subtract 4x from the right-hand side, I'm just going to be left with 7, because 4x minus 4x just cancels itself out. So on that right-hand side, I'm just left with 7. Remember, we worked with combining terms in a previous class. 5x minus 4x is equal to 1x, but if I just have a 1 in front of the x, it's the same thing as just x, so the answer to this is x is equal to 7. Remember, you can always go back in and check to make sure that it works. So if x is equal to 7, I have 5 times 7 on that left-hand side is equal to 4 times 7 plus 7 on the right-hand side. 5 times 7 is 35, 4 times 7 is 28, and 28 plus 7 does give me 35, so this does check. Here's another example of this, where I have x's on both sides. If I go through and if I subtract the 6x from the right-hand side, because I want to get the x's together, I would also need to subtract the 6x from the left-hand side. Simplifying the left-hand side, I have x minus 8, and on the right-hand side, I have 0. Remember, the goal is to get x all by itself. So this is a two-step problem. I have x minus 8 is equal to 0. Now, I want to just be left with the x, so I'm going to add 8 to both sides. If I add 8 to both sides and then simplify, on the left-hand side, I am just left with my x, and on the right-hand side, I'm left with 8. If I go through and I check and make sure by putting an 8 into the x in both of those terms, I'm going to have 7 times 8, subtract 8, has to equal 6 times 8. And if you go through the math, 7 times 8 is 56. 56 minus 8 does equal 48, which is the same thing as 6 times 8. So you can see that this does check. Sometimes you will see equations where you have 2 or more terms on each side. Here's an example. 5x minus 6 equals 4x plus 2. Remember, the goal is to get an x all by itself on one side of the equation. And right now, I have 5x minus 6 and that 4x plus 2. I can work on getting the constants together on the same side, and then also work on getting the x's together on the same side. So I want to get rid of the constant on the left-hand side, so I'm going to add 6 to the left-hand side. If I add 6 to the left-hand side, I have to add 6 to the right-hand side, because whatever I do to one side, I have to do to the other side. Now I'm going to go through and I'm going to simplify. That left-hand side, I'm just left with 5x. On the right-hand side, I'm left with 4x plus 8. I still now want to combine the x's. So now I'm going to go through and I'm going to subtract 4x from both sides. As soon as I subtract 4x from the right-hand side, the 4x minus 4x cancel each other out. I'm just left with 8. When I subtract the left-hand side, 5x minus 4x, I'm just left with x. So x is equal to 8. I will leave it to you to go back and put 8 back in for x in both sides of the equation and check to make sure that it works, and I think you will find out that it does. Finally, remember that it's always possible to have parentheses in a problem, and here is an example. 3 times in parentheses x minus 5 is equal to 2x plus 8. In order to solve this, the very first thing I need to do is use the distributive property and distribute the multiplication of 3 with the x minus 5. So 3 times x is 3x, 3 times 5 is 15. So now the left-hand side is 3x minus 15, the right-hand side is 2x plus 8. Now I'm going to do the same thing that I just got done doing with the last problem, if I could make that a plus. I am going to go through and I am going to add 15 to both sides. if I add 15 to the left-hand side, I have to add 15 to the right-hand side. And the reason I'm doing that is I want to get the constants together on the same side. So now, on the left-hand side, I'm just left with 3x. On the right-hand side, I'm left with 2x plus 23 when I add 8 and 15 together. I'm going to continue now for my next step. I'm going to subtract 2x from both sides. So if I subtract 2x from the right-hand side, I have to subtract 2x from the left-hand side. Simplifying the left-hand side, I'm just left with x, or 1x I could say. In the right-hand side, 2x minus 2x cancels. I'm just left with x is equal to 23. What is really important when solving algebraic equations is to solve them in a systematic way. Always make sure that both sides of the equation are true, and always, whatever you do to one side of the equation, you must do to the other side. This ends the video for section 2.1. Thank you.